I want to talk a little bit about the weather. I figure that's always a safe topic. Um, so this time of year, we've had an odd spring. Maybe all springs are odd, but we've had some dry spells, and then suddenly it'll rain. It may rain across the street, but not in your field. Uh, and I often get questions this time of year uh, about fungicide applications um, and 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 weather and rain. So the title of this talk is Rain Fastness of Vegetable Fungicides. And what I'll try to do is answer some of the questions that I commonly have. This I was asked to give this presentation by a specialist in another state a few years ago who mistakenly thought I knew something about this. So I did some research, and I want to share that with you today. Well, what happened? So the title is Rain Fast. What is that? So there's fancier definitions, but basically the effectiveness of a foliar fungicide application after a rain event. So it's rained. Um, you've applied a fungicide. It's rained. What happens then? Is it still effective? And here's the three the three questions that I want to try to answer today. Um, People ask, should I wait until it rains before I apply a fungicide? So they want to apply a fungicide. It's going to rain tonight or tomorrow. There's predicted rain. Should I still apply that fungicide? The second question is, if I apply a fungicide before rain, how long should I wait? How long should the application be made before the rain? And then finally, I applied a fungicide yesterday and it rained today. Should I reapply? So that's basically the questions that I wanted to answer. And I thought when this topic was given to me, I thought, well, this would be easy. I'll just look up the labels. They're all PDFs. I can search them all, and I'll just find rain fastness on the labels. Um, well, that was a great disappointment. And so I have dozens of labels digitally that I have that I can search, and I went through them and systematically searched them. And right on your screen here, this is the products that I found that actually say something about rain fastness. There's some almost say other things about rain and leaching and stuff like that, but really these are the only labels that has information about rain fastness. So I mean, you can read this, but you'll have anything from 1 hour. What does that mean? Well, that means that if you have, for example, approach on for an hour and it rains, it's rain fast, and your application will be effective. You'll have others that say dry, like here's Propamax that says dry. What does that mean? Well, I assume that means that if the label, if the product dries on the plant before it rains, that it's rain fast. There's others that say yes. Well, that's less clear, but I guess Endora is saying that it is rain fast, but they're not giving a time uh, that it's rain fast after. I also looked for rain fastness information on organic fungicides, and I was similarly disappointed. Um, Basically, I either got no information or information said shorten the interval during raining weather, which is a pretty good idea anyway. So what factors affect rain fastness? And one of the big factors that we'll talk about again and again are contact versus systemic products. And we'll define those in a moment here. Sometimes contact products are sometimes called protectant, but to me, contact products are products that stay on the surface of the plant versus systemic, which is a product, a fungicide that moves into and then perhaps moves in the plant. And here's some when this topic was first given to me, I thought, well, I'll find lots of information on the label, and the first thing I thought of was two contact products. Here's any mancozeb product, for example, dithane. It says rain shield, or chlorothalonil. You think Bravo weather stick, and it certainly the implication there is that these products will say something about rain fastness on the label. In fact, no. So let's define what I mean by contact. So contact fungicides, to me, contact fungicides means that the product has to contact the spore on the leaf. Either it has to be sprayed onto the spore and come in contact with it, or it's sprayed on the leaf and the spore contacts the residue there. All right. Versus systemic, which can move in the plant and perhaps contact the fungus later. So contact fungicides will protect the leaf surface. Sometimes, an example here is chlorothalonil, sometimes fungicides that are contact also have a vapor phase, which means they may move around the surface and become redistributed, and we'll talk a little bit about that in a bit. But basically, contact fungicides are on the outside of the leaf. Systemics, one example would be a translaminar fungicide, which will protect the plant surface by moving into the leaf. They don't move once they're in the leaf, but they move inside the leaf. And you see the graphic here, and they show a fungus inside the leaf. So one can imagine that it gets into the leaf, and that it may contact the fungus once it gets into the leaf. It's also easy to imagine if it rains that systemic products are going to be more protected from the rain. Other systemic products are called xylem mobile. That means they move. Once they move in the leaf, and then they move towards the leaf tip. The vast majority of products are either translaminar or they move towards the tip. Probably not even an inch, but they move towards the leaf tip, and that means that they can move and perhaps contact the fungus once they're inside the plant. There's a few systemic products that are called amphimobile out there. Not a lot, but they'll move either way in the plant, move towards the tip or towards the root, but they're systemic as well. So because I could not find much information on the label, I thought, well, I'm going to have to study this myself and go back and find research papers that looked in this. So what I want to do now is talk about some of the fungicide or some of the papers I did and looked up. And most of these papers, perhaps all of them, they make these kind of rain machines in a greenhouse type situation, or where they simulate rain on the surface of plants, and then they can measure how much washes off. So we're going to talk about contact fungicides first. This first study then is Daconil weather stick, which is chlorothalonil then. Same active ingredient as Bravo, and they found a high loss from rain 60 minutes or less after application. The control with no rain had 100% residue versus with 60 minutes, they lost 60% of the residue. And they concluded, and this is for dollar spot and creeping bent grass, they concluded it's best to apply this chlorothalonil 8 to 24 hours before a rain. So let's remember that, 8 to 24 hours before a rain. Here's another one with chlorothalonil. This is on potato, and they found rainfall on the day of application was the greatest loss of residue. And again, that's that same kind of 24-hour thing we're talking about then. And they found that the residue loss was most from the top of the plant. So you think of a potato plant, and it's vertical there, so the residue sometimes washed from the top of the plant to the bottom. So it didn't completely disappear, but it wasn't useful on the top of the plant anymore. And small amounts of rain removed a large proportion of the fungicide, but then the remaining fungicide was difficult to remove. Here's one with dithane. Also be the same thing as Roper and all those other Mancozeb products. So they were working with a residue that had been on the plant 24 hours. They used 0.6 inches of rain, and they found that reduced the Mancozeb residue by 40%. Newfilm, which is an adjuvant, did not influence the rain fast, and they were working with apple leaves. Seems like people who work on fruit and turf grass have more money to do these studies. So here's another one with a dithane, a Mancozeb product. They had a 1/5 inch of rain. 2 hours after application, they lost 90% of the residue. 4 hours, 75% loss of residue. And after 24 hours, 80% loss of residue. And again, they were working with apple leaves, and they recommended a drying time of at least 4 hours. And they recommended using adjuvants. And I think it's best if you're wondering whether you use an adjuvant, go back to the label and read what the label says. So spray adjuvants, the addition of an agriculture registered surfactant to sprays of diethane, F45, rain shield will improve the initial spray deposit's fungicide redistribution and weatherability, which is really rain fastness in a sense. So that's just a statement from the label. So copper hydroxide and copper oxychloride products, these are products usually used for bacterial diseases. This study looked at 3 hours after application with 0.2 inches of rain, and they found that 80% of the copper washed off. And again, they're looking at apple leaves. Ethyl oxalate, which is an adjuvant, reduced the copper oxychloride, but it did not reduce the copper hydroxide. So the adjuvant situation in that case was complicated. And this is Anna Schindler at Michigan State with contact fungicide. She found with a 24-hour residue, 1 inch of the rain removed 50%, and 2 inches removed the remaining residue. I wanted to kind of move to systemic fungicides now. This one's Secure, which is the same active ingredient as Omega. This one, they call it a contact fungicide. I kind of probably would have called it a translaminar, but some of it is entering the leaf, and they found it was effective 15 minutes after a rain. So if it's applied 15 minutes before rain, it's effective. So they recommended a 1 hour rain fastness, and again, that's bent grass. Here's one with oxystrobin at 50%. By comparison, Quadris F is 22.9% as oxystrobin. And this was effective even 15 minutes, again, 15 minutes before a rain. Brown patch and fall fescue, and again, they recommended 1 hour of rain fastness. Here's another one with Quadris, 1 day old residue. This is Dr. Schindler at MSU again. 2 inches of rain did not reduce effectiveness, but it did reduce residue by 60%, which I thought was interesting. And this is in Phomopsis and grapes. So what factors reduce fungicide residue? Weathering, which could include rain, but would also include wind and whatnot. UV radiation, the sunlight basically, and then growth. So it's easy to imagine that if the plant grows, that part is not going to be covered with fungicides. So let's get back to my questions then. Should I wait until it rains before I apply a fungicide? And in most cases, I would say apply a fungicide before a rain. And I'll have a slide on this later. But basically, rain is needed for diseases for foliar disease initiation and for its spread. So you need to have that fungicide on before it rains. So in most cases, apply the fungicide if you absolutely can before a rain. If you apply the fungicide before rain, how long? So for contact products, 24 hours before a rain. That one paper said 8 to 24 hours. Certainly, the day before is I would certainly put that contact product on. Systemic products are more 1 to 2 hours, but read the label. Some of them do have a comment about rain fastness, and if you have questions, of course, I'll be glad to help you. The other question is, I applied a fungicide yesterday and it rained today, 1 inch. Should I reapply? I would say in most cases, don't reapply immediately, but with a heavy rain, you might want to just shorten the interval. So if you were going to go with a 10-day interval, go with a 7-day interval, for example. But there's a lot of circumstances involved, and again, I'll help you walk you through that. But I don't think I would have put a fungicide application on immediately afterwards. Older residues are more likely to need reapplication, but that's not what most people are worried about. They're worried about a rain that happened immediately after uh, an application. And contact products more likely to need a reapplication than systemic products as we've spoken of. There's more information can be found. I wrote an article on the Vegetable Crops Hotline this year, issue 685, and this is a link if you can get to that, or again, you can talk to me about that. So I just, again, for a disease like anthracnose of watermelon or almost any foliar disease, you need the rain to initiate infection, and you need the rain to disperse the spores. So it's important, if you absolutely can, to have the fungicide application before rain. So we've talked about a little bit about systemics. I want to talk about scheduling contact versus systemic fungicide. So now we've talked a little bit about the greater rain fastness of most systemics than contacts, but now I want to talk about systemics and contact products in terms of when to apply them. Most contact fungicides can be applied back to back. So for example, a chlorothalonil product like Bravo can be applied time after time, and we don't have to worry about alternating products for resistance. But most systemics require some alternation, and that's what I want to talk about. So if you look in the Midwest Vegetable Production Guide, and of course you'll find a lot of chemicals in there, and here's just a table, just a few, and you'll notice some of them will say an M on the label. That means that it's multiple sites of action. You don't really need to worry about alternating these. And we've got, a Coside, Bravo, and Dithane there. And then the ones with the numbers, those are the ones you need to worry about alternation. And of course, at least most recent fungicide labels will have the group number on the label itself. And I've noticed more and more when I talk to growers, they'll ask me and actually refer to the group number. So I think people are becoming more aware of how systemics have a single mode of action indicated by the group number, and then those need to be alternated. So here's some examples of fungicide resistance. This is gummy stem blight of cucurbits. Some outbreaks may be caused by strains that are resistant to fungicides in the FRAC group 7 and 11. We learned that over the last several years. Here's a picture of gummy stem blight. So that means these products, if you were applying these, there's nothing wrong with applying these, but if you think gummy stem blight may be a problem, you also need to put another product, whether it be a contact product like chlorothalonil, or another systemic product that does not have or is unlikely to have resistance to gummy stem blight. And again, I can help you schedule those. Powdery mildew, we know that there's some resistance out there to that in Indiana. So products in the FRAC group 11, the mode of action group 11 include Quadris and Cabrio, and Topsin in group 1. We know that those products don't really work very well for powdery mildew. So it's okay to put those products on, but if you have powdery mildew or you're worried about that, you're going to have to put something else in addition to take care of the powdery. Phytophthora on, in this case, pumpkins. We know that there are isolates out there that are resistant to group 4, so that'll include apron and ridamil, and so you're going to need to alternate or worry about putting something else in for those. Now, bacterial spotted tomato, there's resistance out there, and I said it was a group M, and it is. That's a longer story, but we found that in Indiana, you did a survey a few years ago, about 80% of the isolates are resistant to copper, and there's ways around that, but that's an example of an M group, which there is some resistance to, and I'm working on ways to get around that as well. So let's talk about, so this is a watermelon fungicide schedule. We have the schedule here throughout the summer, and let's say that the red arrows are your Bravo, your chlorothalonil product, and you want to put on a systemic in mid-June and in late July, and you want to use the product Pristine, which has got the group 7 and 11, two different modes of action there. But you don't want to put the Pristine back to back. So in this case, you're going to put the Bravo in there, which has an M for the mode of action in between those, so that you can go ahead and put those two products on. Or if you put the Pristine on there with group 711, you could put the Topsin in there, which is group 1. And for example, both of these would be products you could put on for anthracnose of watermelon, and you'd be okay, because those are different modes of action, and you don't have to worry about resistance. And then you go back to the Bravo, for example. So in summary, then, know which fungicide and diseases may have fungicide resistance. I've tried to give you a few clues here. But the vegetable guide, Midwest Vegetable Guide, has, if you look up products, we try to give you a hint which products may have problems. Alternate or tank mix products that may have problems. And again, I can help you schedule those if you have questions. In general, with fungicide, use the high rate unless you know that a lower rate works for your situation. And again, I can help you work through that. But in some of the products are pretty expensive, and I can maybe help you know when you can kind of skimp on that and when not. But if you don't use at least the lower rate, then that can also increase the probability of getting resistance in the fungicides. And finally, read the label for specific instructions and warnings. Some products will say, oh, you can put this product on twice before alternating, and that's fine if you read that. In general, I think it's always a good idea to alternate, and that's what I've been trying to work with growers to do. That's all I had, and I'll take any questions, or I'll wait until after Fred's talk if that's appropriate.
Dan, it's Fred. What does M stand for? I've not seen that.
Multiple.
That's what I guess.
Multiple sites of action. I used to call it multiple modes of action, and Rick Latin pointed out to me that's not really correct. It's multiple sites of action. So, but either way, it means that it goes into the cell and has it affects the cell in different ways. So even if the cell overcomes the resistance in one location, there's other locations that it can overcome that. I wanted to mention that it may seem to why is there resistance in copper when it's an M, but I think if you think about, bacteria have had to evolve in the earth for millennia, basically, in the presence of heavy metals, and that's why I think bacteria have a way to overcome copper.
Dan, I will have to say, from all my experiences, and they've been quite a few over the years, but this incident probably happened some 30 years ago. I was actually spraying and got rain as I was spraying. One of the storms blew up, so I quit. And by the end of the year, you could tell exactly where I had made my application up to in the melons before the rain, and then after. It was probably a couple of days later before I got back into the field and sprayed again. But I mean, it was distinctive right up to the exact point where I stopped that one spray. So the importance of getting the fungicide on before the rain, kind of verified that in my mind.
I've had other people tell similar stories, and I'm just certain that it's neat. You need to put that on if you can.
I mean, like I said, it was amazing. I mean, and like I said, I mean, it started raining as I was making the application. I don't remember what my tank mix was at that time, but I'm sure it probably had Bravo in it, because that product's been around for many years. But it just amazed me. It was kind of like I should have just kept spraying through the rain, but
Was that your field or?
Yes,
or
that was one of my personal fields back probably in the early 90s. So it's been some time ago.
a good story. Thanks.